Good afternoon, everyone. I hope everything is going on well. Okay, so in the previous session, we had learned about the formation of petroleum. That means how petroleum is formed from the decay of dead plants and animals and marine plants and animals, right? Due to heat and pressure, they got converted and so on. So today we'll be learning about the refining of petroleum. Refining in the sense, as I had informed you, that your crude oil, which is the black, thick, and oily liquid, it can also be used in its original form or natural form. It has to be refined into different useful components. So how we'll be learning that how that is done. Okay, so it's refining of petroleum. First, petroleum is a dark liquid, dark oily liquid. Okay, it has an unpleasant odor. That means it has a very, reeking or foul smelling, pungent smell. You won't be able to bear it. It's a mixture of various components such as petroleum gas, petrol, diesel, lubricating oil, paraffin wax, etc. So there are many things present like petroleum gas that you use in everything, petrol in your vehicles, diesel in engines, lubricating oil to lubricate the machine parts, paraffin wax in candles. And so there is it's a mixture of so many components. Okay, so we actually separate them into different constituents or fractions. Okay, by refining process. The process of separating the various constituents and fractions of petroleum is known as refining. It is carried out in a petroleum refinery. That means a petroleum refinery, you can say a power plant or plant where this process takes place. The place. Okay, and then petroleum is separated into fractions by fractional distillation. We go through this process is known as refining, and this refining is done by fractional distillation. Okay, each fraction has a different boiling point. Different boiling point, like some have low, some have high. Some boil at very low temperatures also, while some boil at high temperatures. Like the boiling temperature of water is 100 degrees Celsius, right? So it is done in a fractionating tower. Fractional distillation method, as I have told you, it's done by fractional distillation, and it is done in fractionating tower. The word of distillation you might have heard, I suppose. Yes, distillation. Have you heard? We have even seen destructive distillation, I think. In the formation of coal, we use destructive distillation, where in the absence of air or limited supply of oxygen, we heat of the coal to produce different products like coke, coal gas, and petroleum. Not petroleum. It's ammonia liquor. Yes, coal gas, coal tar, and so on. So distillation is a very common word which is used, and we say that distilled water is the purest form of water. It does not contain any minerals, and it is neutral. It does not react also. So fractional distillation is also to obtain pure forms or different forms from crude oil. So here is a picture which represents the fractional distillation process. First, crude oil is passed in a furnace in which it has heated, okay, at the degree of 400 degrees Celsius. The bottom of that's why at the bottom, and that is connected through a pipe. Okay, so 400 degrees Celsius is the point for which it is heated, and then like fuel added, it has different levels according to the boiling point they settle. The ones with higher boiling points, okay, they do not settle. Ones which have lower boiling points, they settle first. Lower boiling points, 300 degrees Celsius, 300 degrees Celsius, 200 degrees Celsius, 150 degrees Celsius. Okay, so that's what settle according to their boiling points. Let's see how. Okay, let me explain this process. So it's a pictorial representation over here. We'll see how. Crude oil. First, crude oil is passed into a boiler, or it can also be named as your furnace. It's also known as the furnace, where it is uh, the crude oil is changed into gas. So when this gas is released out, according to its temperature, it starts to settle into its fraction. The gas gradually moves up. When it sees that now it has mixed with all the mixture of your kerosene, diesel oil, and all the oil. So according to the gas different constituent has different boiling point, right? But the gas will also have its different boiling point. So the heavier ones will settle first. Okay, which will have your they have heavier ones, they'll settle first. For example, the gas starts to move up. When you see this settling is of 650 degrees Celsius, it settles down and forms what? Fuel oil. When it sees it's 450 degree Fahrenheit, 850 degrees, 650 degree Fahrenheit, 450 degree Fahrenheit, I'm going to it settles down. Then when it sees it's 350 degree Fahrenheit, it settles down and forms kerosene, and so on. So this is a distillation column. In this, accordingly, we obtain different materials. As each gas reaches a set of different temperature that condenses into liquid, the liquid is separated into its own distilling columns. In its own, it has been formed. Accordingly, they will settle. Okay, according to the gas will settle. And some gases do not settle, okay, and they are let out through an opening out, though they are known as petroleum gases. They do not settle down because they are so light that they are unable to condense themselves. Okay, with lower boiling points, they settle at love. Okay, that means what do you understand by boiling points? Let me first check that. Okay, in order to begin with our next thing, first let's see what do we understand by the term boiling points. Boiling points. You have one higher boiling point. That means water boils at 100 degrees Celsius. So its boiling point is 100 degrees. Now, if any substance boils at 25 degrees Celsius, that means it has lower boiling point, right? And it boils at 25 degrees Celsius also. And if a higher boiling point, that means it boils when it is given more temperature. Okay, for example, we see over here the fuel oil. If you notice the fuel oil, okay, it settles at 370 degrees Celsius itself. It means it has higher boiling point, whereas 300 degrees Celsius has lower boiling point. So once with higher boiling point, they settle first. At the bottom itself, they start settling. And once with, but if you see, you might count first from top to bottom. And the bottom area is for higher boiling points. And these have lower boiling points. Fine. So the ones with higher boiling points settle first, and ones with the lower boiling points settle afterwards. So let me explain each of them by writing in a stepwise manner. So the first step is your petroleum or crude oil is heated in a furnace. You have seen the pictorial representation, furnace, or even a boiler, you can say. It means the boiler. The second process is it turns vapors into vapors and is passed to the bottom of fractionating tower. Okay, that the third step is the gases condense according to their boiling points. Boiling points. The ones with higher boiling points settle at the bottom. Bottom. Examples of fuel oil or lubricating. The gases which do not condense, they are known as the petroleum gases, come out as vapor. Okay, from the top of the tower. This is the whole process. Now you might be wondering that in this picture I had shown you like 650 degree Fahrenheit, 1050 degree Fahrenheit, and so on. But here I have shown you, 370 degrees Celsius, 10 degrees Celsius. It varies, right? You might be wondering. So you can take anything, the standard thing. You can take 400 degrees Celsius. They are heated to. Okay, they are even if you done into Fahrenheit also it is possible. It's accordingly. Okay, it's your wish. Whichever you want, you can take it. Okay, however you want to go with, you can take it. Okay, according to your wish. Okay, so I hope you all understood this much. Let's move to our next thing, and that's few questions to be solved. So as to be moving here with it. The first question is process of separation of different constituents from petroleum is called. They are asking about the process. Roots of fractional distillation. It is refining. It is known as refining. Dash, 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 and dash are obtained by refined petroleum. You can list down the product like petroleum gas, paraffin wax, diesel, kerosene, lubricating oil, and anyone. Many things are obtained. Accordingly, you can give bitumen. You can bitumen, fuel oil, your way. Okay. So these are few products which are obtained when we refine petroleum. Okay. So here's a table representing the uses of different components that we obtain. Okay, what are their uses? First is the petroleum gas, that is LPG. What is the full form of LPG? Liquefied petroleum gas. Remember that this liquefied petroleum gas is actually in gas state, okay, but it is compressed into liquid and kept in cylinders. What is it used for? Used for fuel for home and industry in cooking. And petrol we use for motor fuel, aviation fuel, solvent for dry cleaning. Solute and solvent you might be aware, like solute is the salt, solvent is water, and the solution they form is the salt water. Okay. Kerosene. Kerosene is fuel for stoves. Stoves just in fuel for stoves also, lamps also, for jet aircrafts also. Diesel we use for heavy motor vehicles. Okay, then electric generators. That's why diesel is used in your train. We have seen, yes, diesel trains and all. Okay, electric generators also. Lubricating or lubricating the machine parts. Yes, we have a kind of oily substance that is a lubricating oil in the machine parts. Okay, I think to stop the friction or reduce the amount of friction. Paraffin wax. Paraffin wax is used as ointments, candles. You're burning candles. And the Vaseline. Okay, bitumen. Bitumen is paints and road surfacing. Okay, So these are the uses of different components that we obtain. I hope you all understood till here all about fractional distillation and refining of petroleum, the procedure, and the uses of different components that we obtain. And thank you. If you have any doubts, kindly place it in the